So we are talking about the digital voltmeters, and I had discussed one type of digital voltmeter, that is the RAM type DVM. Its block diagram. This is its block diagram, and in this case, basically, the in all digital voltmeter we measure DC voltage. And as I told you yesterday, also, if we are interested in measuring AC voltage, then we have to convert it into. Not we are required to convert it because converter is part of the DVM. It converts into the corresponding value of DC, and then it is converted with all these functional components. It is converted into the time, and the time is in form of the clock pulses, and it is counted. So depending upon the voltage level, your count will be high and low, and then it is calibrated in terms of the unknown voltage. This is how this is done, and then I explained it with the help of ramp voltage is the center of this particular concept, and this is used, and depending upon from the unknown voltage level to the ground level potential, how much time does your ramp voltage takes. That is basically the basis of the measurement, and this is how it is done. So this I discussed this RAM type DVM on the last run in detail. If anybody is having any question regarding the RAM type DVM, you can ask, please. Now the next one is dual slope type DVM. This also I discussed yesterday. Means the basic concept I discussed. So um, the 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 main building block of dual slope type DVM is basically integrator. So in this case also, the means the basis remains same. Here in this case also, the unknown voltage is converted into the time, and then time is measured. Although the way of doing this is different, and that's why we are having different DVMs. So basic concept remains same. So in this case, as I told you yesterday, that when we apply a DC voltage to an integrated, then we'll get a RAM. So we connect the unknown voltage. So two voltage sources here means as far as the basic things are concerned. So it is an integrator, and obviously a known voltage, and a reference voltage is also the integral part of the dual slope type DVM. This reference voltage, I'll come to that. How does this uh, DVM works? First of all, the unknown voltage is connected to the integrator. Obviously, depending upon the polarity of this unknown voltage, your output will be a ramp voltage, whether it is a with the positive slope ramp voltage or negative slope, depending upon the polarity of the input. So this means your integrator is connected to the unknown voltage, or your DVM is connected to the internally. This all is internally, although externally the connection will be the full time, means permanent connection, means you will make the connection. So it will be connected to the unknown voltage for a fixed period of time, and accordingly your output will either ramp up or ramp down. Then it will be connected to reference voltage. Now the polarity of the reference voltage will always be opposite to that of polarity of the input voltage. Whatever input voltage you have provided, the reference voltage, it will be done internally. So a reference voltage will appear to the integrator, the opposite with the opposite polarity to that of your input voltage. So obviously, um, uh, in this case, so if you, in response to the unknown voltage, if your after fixed period of time, that I told you that it is connected to unknown voltage for fixed period time. So if in this case, because polarity is different, so when if the output is ramped up because of the connection of unknown voltage, then obviously the output will ramp down will when connected to the reference voltage, because the polarity is opposite. Or if in this case, if it is ramped down, then in this case it will be ramp up, I mean the case of V reference. So this way, um, your I just want to show you that's it will be, you will be able to understand. So in this case, you see, first of all, your input voltage, your unknown voltage is connected to the integrator, and suppose as per the polarity of it, your output voltage is ramping up, and for the fixed period of time, suppose it is t1. And then it is connected to, after this fixed period of time, it is connected to the reference voltage, which is having a in reverse polarity, opposite polarity to that of your unknown voltage. So obviously your output will ramp down and will connect it till your output voltage reaches to zero. So depending upon the input voltage, your unknown voltage, this part will have its slope. Now suppose the voltage is high, so it will have sharper, higher slope. So in fixed period of time, it will reach it will reach to the higher value. You understanding what I'm saying? And obviously if it is less than, uh, having lower values, so it will reach to the, and obviously when it, as far as the reference voltage is concerned, in all cases, whatever is your unknown voltage, your reference voltage remains same, although its polarity will be opposite to that of input voltage. So when your voltage is high, then we are connecting it to the reference voltage. When unknown voltage is high, when we are connecting to the reference voltage, it will take more time to reach to the ground potential, zero value, like this, like this. And if it is less value, then it will take less time. So this is how your voltage level is connected, is basically converted into time. You can see for different voltage, it is having different time to reach to the ground potential. So this is how your voltage level is converted in this case in dual slope type. So you can see that it is having one slope when it is connected to the unknown voltage, and it is having another slope when connected. So that's why it is called dual slope type DVM. So this is how basically your dual slope type DVM works. So here in this case, this is the value, because initially when you are connecting your unknown voltage to the voltmeter, your output will be zero, because we are having integrator. So integrator is having property to retain its last. So initially it will start, means when your output is zero, so it is connected for fixed period of time, whatever is the voltage, your unknown voltage is connected for a fixed period of time. And as far as the reference voltage, your reference voltage is same, whatever is the input unknown voltage, but it will be connected to the integrator. And it is all, whatever I explained, it is all done internally to the voltmeter. We are not required, user it not is not required to connect it and then remove it, then like that. and polarity selection of the reference voltage, all is done internally. So this is the, you can see that if voltage Vx is the known voltage with the positive polarity, then output will be minus Vx upon RC T1, because this is the integrator output for the fixed period of time. And now you can see that we connect um, uh, the integrator or the voltmeter to the reference voltage, and we keep it with the reference voltage till the time your output is becoming zero. So in this case, V out will be V1, whatever it was having earlier output, this V1 when we are connecting it. Then V ref upon RC plus T, and this plus sign is coming because in this case V refs will be negative, because your unknown voltage is positive. So we'll put this value V1 and you see the final value will be V out will be 0. So you can see that this is the expression we'll get, the V1 expression we are putting here, and this is the, so here you can see that it is T1 fixed period of time, and it is Tx whatever, it will have different values. So finally you can see that Vx will be the known voltage will be equal to reference voltage times your the the time it will take to reach to the zero value, and this is the fixed. So you can see that T1 is fixed, reference voltage is fixed, so Vx is proportional to Tx. So this is how this in this case the concept remains same, that your known voltage is converted into the time, and then this time is measured, and then it is multiplied by the coefficient value, constant value. So this is how dual slope type DVM works. If anybody is having any query regarding it, you can ask. Ye, no query.
No, sir.
Okay. How many you have joined till now? Around 7, 16, 15 people rather. Why attendance is so thin? Um, Most of the time it is only when I take the attendance, then people start joining. I don't know what is the attraction in attendance. Nobody is asking about the attendance, but you people are fascinated about the attendance and not about the subject. Anyway, so this is your, and this is a diagram, you can say that not entirely the functional diagram. You can say that this is your electronic switch, which basically um, connects the integrator to the unknown voltage and to the um, reference voltage, and then internally reference voltage polarity means Vx polarity is determined, and accordingly polarity of the unknown voltage, sorry, reference voltage is selected. This is all. Then this is your integrator, and this is your gate. And when obviously your your
And
integrator
gates, and
output
gates.
is more than zero, more than means one, you can say, and then it will get is open, and then clock oscillator. So this flow remains same in both the cases. This flow means if you'll check your RAM type also, this flow remains same. Only thing is that the window, how we are opening the window, that is different. So here in this case, we are opening the window using integrator. So and where the slope of the input voltage and known voltage plays important role, and reference voltage part. So that's why it is called dual slope type DVM. So this is only the functional diagram altogether. Now the third DVM is
सर
successive
प्रीवियस
approximation.
पेज सर.
बताइए
सर प्रीवियस पेज सर, ये डिस्प्ले से पहले वाला बॉक्स में क्या लिखा है?
क्या चीज?
सर डिस्प्ले से पहले वाला बॉक्स में काउंटे करके
काउंटर
कुछ
काउंटर
काउंटर.
काउंटर
ओके सर, ठीक
it
है,
will
चलो.
count,
ओके सर.
it will count the clock pulses. जी, क्योंकि आपका टाइम जो है, as I told you that for higher voltage your time will be more, means your voltage will take more time, output voltage, integrator output will take more time to reach zero value. So obviously your window is open for
Sir,
more.
so after counting the pulse, control logic will reset the counter every time.
No, no, this is like that. You have to, every time you have to reset the counter, because if your voltage is changing,
Yes, sir. That's what I'm asking.
so if you are carrying the older reading, then it will be erroneous. So whenever, means actually in digital circuit, digital instruments, this is very important part. In analog it is all automatic, that whenever your voltage you are connecting to the voltmeter, if changes your out response changes, जो आपकी रीडिंग है वो चेंज होती रहती है. लेकिन here in this case you have to refresh it, and then in all digital instruments it acquires, because it is a discrete takes the discrete readings. So it takes this, means if you means I'm talking about the
It's a continuous change in the reading. It was not
sorry,
stopped for a moment.
I'm sorry, if I'm talking about the DC voltage, so if this is your DC voltage, and it is maybe varying with time, like this. So if you are taking one reading here, you took your digital instrument, this is Vx you applied. So and then you're sitting, then you are not, means although your voltmeter is connected to the circuit, but if you are not acquiring more samples, then it will keep on showing this value only. Okay, so to update your output, we acquire the samples at certain rate. That's why it is, sampling rate is one of the important. Yesterday also, with reference to your RAM type DVM, I discussed this thing. So so like if you are acquiring um, um, one sample per minute, so every minute, after some time, after 1 minute it will pick another sample. After the next 1 minute it will pick another sample from here, from here, from here. So obviously if there is any change, then you will your, and whenever we are going to acquire next sample, obviously you have to reset your counter here. So this your control logic will give, means it will give the pulse to the electronic switch to start all the function afresh, that it should connect the unknown voltage to the integrator, and after some, for a fixed period of time, then connect the to the reference voltage, and so on. So obviously when you are starting to acquire the next sample, then you have to reset the counter, although your display may be displaying while this processing is going on, it may be displaying your old reading, but once it is done, then your display will hold the another reading, the fresh reading. Another thing I told you, that if any change, you must be aware how fast your signal is changing. How fast is your signal is changing. So if any change which is taking, suppose your sampling time is one sample per minute. If any change is taking place in between, any voltage change is less than of 1 minute, then obviously it will get skipped. So you know that how fast your signal is changing. So accordingly, you should choose your sampling time, or your voltmeter, digital voltmeter. It should have the sufficiently fast sampling. So this is all is the part of the game, you can say, that you should have a good knowledge, and this is in all digital instrument, this discussion is basically um, relevant. Even if you are using A to D converter, you know it, sampling time is a very important specification of the A to D converter, analog to digital converter. So it is fine. Somebody asked the question.
Yes, sir. Yes, sir. Thank you, sir.
You are not responding. आपने मुझे बजा दिया, मैं इतनी देर तक बजता रहा, और आप इसको
नहीं
एक्नॉलेज
सर,
भी नहीं
नहीं
कर
सर,
रहे
नहीं
हैं।
सर, मैं
हाँ,
सुन रहा था सर, मैं सुन रहा था,
बस
साइलेंट
ऐसे
होके
ही
सर
पूछ
सुन
लिया
रहा
था
था।
आपने, हैं?
नहीं, ऐसे नहीं पूछा था सर, मेन वहाँ पर सर काउंटर के समझ में नहीं आ रहा था, बॉक्स के वर्क क्या कर रहा है डिस्प्ले में। तो वही फिर उसने सर, आपने बस बताया सर, तो फिर अभी ठीक है कि मतलब सर वाट मीटर के जरिए सर आपने ग्राफ के
Anyway,
समझा
I'm
दिया।
here to tell you, but if you want to understand something, then accordingly you should. If you, even if after my explanation you are not getting the point, then you can ask and you can interrupt me. Uh, Main thing is that you should understand. If you are sitting with me here, you should understand the subject correctly
यस सर, यस।
and clearly. So, should I proceed, or you are having still your your query
नो
is
सर,
open?
नो सर,
Huh?
विशाल प्रोसीड।
Should I proceed?
यस सर, यस, यस प्लीज।
Now, the next type of DVM is called successive approximation type of DVM. This technology, you can say, is entirely different from the last two technologies. Last technology used by last two DVMs, RAM type and dual slope type. Over there, your signal is your voltage, unknown DC voltage level is converted into time, and then time is measured, and then it is calibrated, then finally it is calibrated in terms of. Here the situation is entirely different. The technology is, although it looks this diagram looks very complex, but it is very interesting, I'm telling you. And same technology is used for analog to digital converter, for making analog to digital converter also. Anyway, so here you can see that it is having basically the from where should I, anyway, this is your input. The voltage that we are interested in measuring, it will be applied here. Then ranging is done, basically attenuation and amplification means ranging is done. Then this is sample and hold circuit, means it acquires one sample and it holds it. This is all digital instruments, because it is a discrete type of instrument. Then uh, then it is start with the, this is a control register, this is a control register. And here we have, I've taken it as a 8-bit control register. You must have studied registers and all these things in your microprocessor, so you must be having idea. So it is digital registers, which can hold 8 bits. Here in this case, we have taken it 8 bits. It's not like that it is always 8-bit. It depends upon your requirement. We'll come to that, but here in this case, you can see that it is holding 8 bits. So this is all digital to analog converter. This is a reference supply to. So in this case, whatever digital word, 8-bit digital number is stored here in registered, it is converted into the voltage using analog voltage value, using your digital to analog converter. And this voltage is basically compared with the with your input voltage, whatever input voltage you have applied. And then this may be, your input means there is two possibilities. This is a comparator that I explained on the last turn. So depending upon the value of unknown voltage and the output of the DAC, that is corresponding to the content of the control register, your output either will have plus VCC, or it will have minus VCC, or it will have 1 or 0. And then accordingly your gate will be open or closed, and this way. And then there is a ring counter, obviously, that basically resets or increments or decrements the content of the control register. So this is how. And finally it will converge to certain value, certain content of the control register, and corresponding to that value it will be, so that value will be most close approximation of the input voltage. Whatever input voltage and known voltage you applied, that will, our final output will converge to the closest value. So that's why it is called successive approximation type. So now I'm starting, and I want that you should get ready to understand how does it work. And it is very interesting and very easy also, but only thing is that you should be attentive. So SAR, that's what I had written here. It is basically successive approximation register or control register, and this is your multi-vibrator, your this multi-vibrator, and I'll come to each and every. First of all, I want to explain the main function. So in this case, when we start the start button after connecting the input voltage, when we start the start button, then this start button, initially your control register is empty, means it is 0000. When we means after connecting the input unknown voltage to the voltmeter, we push the start button, then this action will set the most significant bit of the control register. So obviously earlier it was all 00. Then when it will be connected, the most significant bit is set. Then we will have this will be the content of your control register, because we have taken 8 bit. You can have more than 8 bit also, or less than 8 bit also, depending upon the that I'll come to that. How can you decide? So now obviously the initially, whenever your successive approximation type of voltmeter, its function will start, then your control register, your successive approximation register will set the most significant. Before that, all the bits will be reset, means 00 is the content. And when it will start, then it will start from here, that your most significant bit will be set. And obviously the the this content, that 1 0 0 0 0 0 will be applied to the DAC, and corresponding value of this voltage corresponding to this value will get here, and this voltage will be compared with the unknown voltage. So again, you see there are two possibilities: whether your unknown voltage your unknown voltage is more than the DAC output, or it is less than the DAC output. So if your Vin is more than the DAC output, then this control logic will retain the bit that was set at the starting. In this case, your first bit is set. So if your output voltage of the DAC corresponding to the content of the control register, if this output voltage is more than the unknown voltage, then we will retain it. The logic will retain it. Okay. And if it is other way around, if in is less, your unknown voltage is less than this DAC output voltage that is corresponding to the content of the control register, then this bit will be reset again. This bit will be reset again. So that's why, that's what and as far as the conversion is concerned, so in this case, corresponding to this value, corresponding to this, if you, if we are counting, we are having 8 bit number, and we are counting from 00 to ff, 00 to ff, number of counts, how many number of counts are there? Can anybody tell? If we are having 8 bit, obviously the 8 bit number range is from 00, if we are talking in terms of hex, from 00 to ff. So how many counts are there from 00 to ff?
Yes, sir. What's the question?
कितने काउंट्स होते हैं?
सर सर चार
यार
बिट
ये
का
तो
एक
बहुत
ग्लोबल
बेसिक चीज
होता
है,
है
आप
बस।
लोगों को मालूम होनी चाहिए।
और सर
कोई भी पूछ
चार
सकता है,
बिट
आपको
का एक
इंटरव्यू में भी
ग्लोबल होता
पूछ
है सर,
सकता है।
8 बिट्स का एक बाइट होता है।
अगर 8 बिट नंबर है, 8 बिट नंबर कितने कॉम्बिनेशन बनाए जा सकते हैं 0 1 के 8 बिट नंबर?
8 बिट के सर 8 फैक्टोरियल।
जी
8 फैक्टोरियल
भाई ऐसे बोलो, मुझे
तो
सुनाई
टू दी
पड़
पावर 8।
रहा है।
सर।
टू दी पावर 8।
कितने? ये लिखा भी है मैंने नीचे यहाँ पे, टू टू
तो
द
टू टू
पावर
दी
8।
पावर 8 128।
2 to the power 8 ये कितना होता है? 256 नंबर्स हो सकते हैं। ठीक है, तो ये आपका जो डैक काम करता है वो यही करता है कि दिस इज योर रेफरेंस वोल्टेज, this is your reference voltage, so it divides the reference voltage with in 256 steps. 250 if we are taking 8 bit number, so your 00 corresponds to 0 volt and your ff corresponds to the reference voltage, and this 1000000 is basically, it is midway count, that is 128. So obviously this they corresponds to the half of the reference voltage, half of the reference voltage. So what is the meaning? If you are having 5 volt reference supply, then when the input DAC input is 00000 all 0, then you will have 0 value here at the output, and when it all are 1 1, that is FF, then you will have 5 volt. And when it is having 1 0 0 0 0 0 0 0, then you will have 2.5, that is 1/28th count. So this is how your DAC. So that's what I tried to explain here, that when this is the content, then output of the DAC will V reference by 2. It will be compared V reference by 2 with the unknown voltage here, and if your V ref by 2 is less than V in, then we'll retain it. That the bit that was done, that was set at the starting, will retain it. And if it is your voltage is less than, your V in is less than the output of the DAC, in this case we'll reset it. So this is the first step. So if anybody is having any question regarding this, it's a very interesting, I'm telling you, step by step I am taking you. So if anybody is having any question regarding it, you can ask please, but make it fast. जब भी आप यहाँ जब भी ये स्टार्ट करेंगे फंक्शन सक्सेसिव अप्रोक्सीमेशन टाइप ऑफ वोल्ट मीटर, तो जो कंटेंट होगा कंट्रोल रजिस्टर का इनिशियल कंटेंट, दैट विल बी 1 0 0 0 0 0 0, उसके करस्पॉन्डिंग जो आउटपुट होगा वो वी रेफ अपॉन 2 होगा। वो इसको हम कंपेयर करेंगे विद द अननोन वोल्टेज। अगर अननोन वोल्टेज इससे ज़्यादा है तो हम उस बिट को रिटेन करेंगे, और अगर उससे कम है तो उस बिट को जो है ये अगर आपका V in is less than this, then we'll reset it to 0 again. So our whatever is the situation, whether we are retaining, depending upon this comparison, whether we are retaining it or we are, then we'll go to the next cycle, measurement cycle. So in next ring counter, what ring counter will do? Ring counter will set next most significant bit. In the first one, it first most significant bit was set, and then it will depending upon these two values, it will be retained or it will be reset. But in the next measurement cycle, the next most significant bit will be set, and then corresponding value of the voltage will get, then again it will be compared with this, and same thing will happen. So this keeps on. So that's what I had written here. So ring counter then advances one count. So here it is written that DAC output is compared with the unknown voltage by comparator. In case unknown voltage exceeds the DAC output voltage, the comparator produces the output that causes the control register to retain one. If unknown voltage is more than DAC output, then we'll retain that bit, and otherwise we'll reset it. So then ring counter will advances one count, setting the next most significant bit to 1. Now suppose earlier it was less than your means here in this case it was Vref by 2 was less than the input voltage or the unknown voltage, so we retained it. Now in the next cycle, your content of the, because it will set the next most significant bit, your content will be 11000000 obviously. और इस केस में जो DAC आउटपुट देगा वो Vref by 2 corresponding to this bit and Vref by 4 corresponding to this bit, so it will be 3 Vref by 4, and then again it will be compared. Obviously this all mapping is with respect to the counts, so this is 192 is because is the 3 by 4th of 256, so that's why 3/4 of the Vref will appear, and again this will be compared. Now whatever is the output, it will be compared with the, sorry, with this, and logic will remain same, that if Vin is more than this voltage, then we will retain that bit, and if it is not, then we'll reset it. So you can see that suppose in this case it is more than that, then your bit is reset, and then your content of the SAR or control register is becoming again 10000000. Then next time it will set the next most significant bit, means this bit, so it will become 1010 and 000, and the output will be Vref by 2 corresponding to this, and Vref by 8 corresponding this, it was Vref by 4, and then this is Vref by 8. So this, and then again it will be compared, and if this value is less than the Vin, then we'll retain it, and if it is more than Vin, then it will again reset it, and then it will set the next bit. So this is how it will keep on going, and then we converges to the final value, and that is displayed, and that is the most close approximation of your unknown voltage. So if anybody is having any question whatever I explained just now, I'll take one example also, then it will be more clear to all of you. But here, so that's what I had written: measurement cycle proceeds through the series of successive approximation. Finally, when the ring counter reaches its final count, the measuring cycle ends and digital content of the control register is final approximation of the unknown voltage. So this is how. So how many measurement cycle will take place in this case? Number of measurement cycle depends upon what? G.
It will depend upon the approximation. मतलब कितनी बार हम कर रहे हैं
G.
सर, कितनी बार approximation कर रहे हैं उस पर डिपेंड करेगा ना.
Number of
approximations मतलब कि कितनी बार हम
वही
रिटेन
मैंने
किए.
नंबर ऑफ अप्रोक्सीमेशन कितने बार होगा यहाँ पे, वो किस चीज के ऊपर डिपेंड करेगा? जो नंबर ऑफ अप्रोक्सीमेशंस हैं वो कितनी बार होगा, या इनफाइनाइट टाइम्स होगा?
सर मे बी फ्रीक्वेंसी ऑफ एसी वोल्टेज.
वाह वाह वाह,
सर आपने डीसी इनपुट दिया था, मैंने जानता हूँ, लेकिन सर
ये इसमें डिजिटल वोल्टमीटर में डीसी जाएगा। भाई आप लोग समझते नहीं है, असल में घर पे बैठ के आप लोग क्लास करते हैं या जहाँ पे भी, यू डोंट कंसंट्रेट, और ये पढ़ाई कोई ऐसी चीज़ नहीं है कि जो बस आप बैठे रहते कैजुअली कि अरे बकने दो सर को, बाद में देख लेंगे, रट लेंगे, देख लेंगे, इधर उधर से ऑनलाइन एग्जाम है उसमें किसी, लेकिन ये दिस आर ऑल कॉन्सेप्ट फॉर यू। भाई ये नंबर ऑफ बिट्स जो है कंट्रोल रजिस्टर का जो साइज है उतनी बार चलेगा ये, क्योंकि हम एक एक बिट को सेट कर रहे हैं और उसको सेट और रीसेट कर रहे हैं अकॉर्डिंग टू दिस कंपैरिजन। तो जाहिर सी बात है कि जब ये एग्जॉस्ट हो जाएगा तो आपकी मेजरमेंट साइकिल खत्म हो जाएगी, जो भी फाइनल कंटेंट होगा दैट विल बी द बेस्ट अप्रोक्सीमेशन। तो इतना कॉमन सेंस कि हम आप इतनी देर से बोल रहे हैं, आपको समझाने की कोशिश कर रहे हैं, आप समझते ही नहीं, आप चाहते ही नहीं कुछ। It is your choice. Anyway, I am doing my job. But if you concentrate, it is a bilateral process, then obviously your outcome will be good. You understand the subject, you will understand something, and it will be good for you also. I'll have satisfaction that I'm able to convey something, deliver something to my students. But ultimately, you'll get benefited if you're understanding or concentrating. I don't know why you are wasting your time. I'm here to discuss each and everything. If you are not able to follow anything I'm trying to explain, you ask me. But sitting idly in front of the computer or doing something nonsense and not concentrating on the lecture, it won't help you. I don't know why you don't concentrate. Once you are sitting in front of your computer, or you're not sitting doing any other thing, why you are doing any other? Anyway, this is my duty I'm doing. So in this case, you see, because you see the procedure that I explain, every time one of the bits are set, and then accordingly, um, uh, on the basis of the comparison, it is set or reset, it is retained or it is reset, and then we go to the next bit, then we go to the next bit, then we go, and same thing is comparison and setting, resetting, in same thing is done, and finally we are reaching here. Obviously, then some of, depending upon this comparison, some of the bits will be set, some of the bit will be reset, and we'll have certain number, and corresponding to that number we will display that output. Basically this will be displayed here, and obviously this will be the closest approximation of the input voltage, unknown voltage. And this is what I try to explain you. And if anybody is having any question, you can ask. I asked that question only just to find out whether you are concentrating, you are trying to understand it or not. Anyway, now I took one example. Now if even if you are not able to concentrate on this part, whatever I try to explain you, if you concentrate on this example, then you will understand. This is one more chance to all of you, that if you concentrate on this example, then you will be able to understand the working of your successive approximation type DVM. Should I start? I again request to all of you, I beg to all of you, that you concentrate, you'll understand. It is very interesting.
So
Should I
this
proceed?
I
Should
will.
I start?
Yes, sir. This time I will sure come.
So in this case, this is your unknown voltage. This 1 volt is unknown voltage. I have drawn a line here. This is 1 volt line. This we are applying 1 volt. We are applying here. Here, this 1 volt is applying, and then your we'll push the button. Then your control register first, the most significant bit will be set. So your most significant bit will be set, and your reference voltage you see is 5 volt. This reference voltage to DAC is 5 volt. So obviously, when the first bit is set, so the control register content will be 1000000, and corresponding to this, the output of the DAC, this output will be 2.5 volt, and this is your 1 volt. This is 2.5 volt, this is 1 volt. So obviously your unknown voltage is, your DAC output is more than unknown voltage, so we'll reset it. We'll reset this as per the logic. बात समझ में आई? ये हमने रिसेट कर दिया, क्योंकि आपका जो डैक का आउटपुट है वो ये है, और हमारा अननोन वोल्टेज ये है। तो अननोन वोल्टेज जो है ज़्यादा है, ये डैक का आउटपुट ज़्यादा है अननोन वोल्टेज से, तो हमने जो भी बिट सेट की थी जिसकी वजह से ये वोल्टेज मिला था, हमने उसको रीसेट कर दिया। तो अब नाउ योर कंटेंट ऑफ द कंट्रोल रजिस्टर is coming back to the 0000000. Is it fine to all of you?
Yes, sir.
Yes, sir. Yes, sir.
ठीक है। अब उसके बाद ऑब्वियसली जो नेक्स्ट आइटरेशन में your ring counter will set next most significant bit. So your next most significant bit is set here. Now the content of the control register 01000000। तो इसके corresponding जो वैल्यू होगी वो Vref upon 4, that is 1.25 volt. Again this 1.25 volt is more than unknown voltage, so this bit will also be reset. Then again we are coming back to the 0000000. Is it fine? Now
Yes.
the ring counter will set the third most significant bit. Now the control register content will be 00100000. Corresponding to this value, vref upon 8, that is 0.625. Now you can see that this value of the DAC output is less than unknown voltage. It is less than unknown voltage. So we'll retain this bit, and we'll retain this bit. Then we'll go to the next iteration, next measurement cycle, and the next most significant bit will be set. Now in this case, your vref by 8 and vref by 16 plus vref by 16 will be the output. So this is coming out to be 0.932937. So this is the 0.9375 is the output of the DAC, and it is compared with the unknown voltage, then it is less than 1 volt. So this bit will also be retained. So you can see that your bit is retained here. We are not resetting it. So now the content of control register is 00110000. Now the ring counter will set next most significant bit. So it will be the content of control register will be 0000111000, and corresponding to this DAC output will be 1.093. So this 1.903 is more than unknown voltage 1 volt. So this bit will be reset. So again we are coming back to, so here I have written reset, here I have written set, reset. So we are coming back to the previous value, that is 00110000. Then in the next case, next measurement cycle, your next most significant bit will be set, and corresponding to this value is 1.0156. This is again more than the unknown voltage, so it will be again resetted. So you can see that successive approximation is going on. And then again next most significant bit will be set, that is last but one. So corresponding to this, the output of the DAC will be 0.9766, and it is less than the unknown voltage. So we will retain this bit, and then finally we'll go to the last bit, and it will be, and again in this case also your output is 0.9961, so it is less than 1 volt, that is unknown voltage, so we'll retain. So your display will display this voltage as a 0.9961 volt. That is the closest approximation of the 1 volt. This, and you can see number of measurement cycle is equal to number of bits or size of the control register. So we have taken 8 bits, so this is how successive approximation type of DVM works. And obviously your final value is having certain error, and if error is with satisfying your measurement accuracy, then we'll retain it, and if it is not satisfying, then what will you do? अगर satisfy नहीं कर रहा तो आप क्या करेंगे? You think about it by the time I'll take your attendance. Roll number 1.
Yes, sir.
Roll number 2. 3.
Roll number 3, present, sir.
Okay. 4. 5. 6.
Present, sir. Roll number 6.
7. 8. 9. 10.